So what we're going to do here are what are called transformations. It's where you take something and you change it. So we're going to talk about what's called the linear parent function. That's the one that doesn't have any changes made to it, like the quote unquote standard one. Okay. And it is just y equals x. Just y equals x with nothing else with it. So, can you listen? What would be the slope of that? Now, the slope is whatever's in front of the x. If nothing is written there, what is it understood that that number is?
1 to 5.
No.
1.
1. Thank you. If there's nothing written, it's understood to be a 1. It's 1x. So the slope is 1. And the y-intercept is whatever gets added on. Remember, y equals mx plus b? It's y equals 1x, but it's plus nothing. There's nothing there. So what do you think is your y-intercept? Well, if there's nothing there, 0, 0, the origin, which is actually also the x-intercept because the origin is on both of the axes. So your slope is 1, and your y-intercept is 0, 0. So I'm going to graph my parent function with pencil. We're going to make that be the like standard one. And then I'm going to use different colors for the ones that we transform. So what I want us to do is go ahead and graph this parent function on each of the grids here. So can you watch? We're not using the colors yet. We're going to just graph the parent function with the pencil, the one that hasn't had any changes. Okay. So you're going to start at the origin and the slope is 1. So you're just going to go up 1 over 1. So if you can count to 1, you can do that. It should look like that. And I just want you to please go ahead and do that on all 3 of the grids, because my idea for what we're doing here is you're graphing the one that doesn't have any changes, and then you can compare it to the ones that get transformed. So you can see them all on the same grid and they'll be color coded and you can tell the difference between them. So I just want you to go ahead and graph that on all 3. So it goes through the origin, slope of 1. That's your parent function. So the first type of translation we're going to do is a vertical translation. That is going to move the graph up or down. Vertical means up or down.
Up or down.
Now, please use your common sense on this. Hey guys, if you take x and add 4, do you think that moved the graph up 4 or down 4? Up 4. That one is going to go up 4. And so what I want you to do is take your first color. It doesn't matter what one yours is. I'm going to just put a green star next to that. I know they don't show up real great on the projector, but just I'm color coding that one green. And then over here on my grid, now here's where I really need you to watch. Instead of starting at the origin, I'm going to count up 4 units and start at 4. Instead of starting here, I just shifted it up 4. The slope didn't change though. So the slope is still 1. What it's like is you just picked up the line and moved it up 4 units. That's what we're doing. So it should look like that. Just went up 4. You picked it up and scooched it up 4 units. Please don't overthink that. Plus 4, moved it up 4. That's all it is.
Yeah.
And so those lines are what? What would we call lines like that?
Big line.
That go along and never touch?
Yeah.
Good. You're ready for geometry next year. Parallel.
I'm actually already in trigonometry. I just take this class.
Okay. All right. This one, hey guys, do you see how it's -2? I need everyone to collectively focus here. What do you think that means happened to the graph? Went down 2. Plus means up, minus means down. Please come with me on this. So I'm going to make that one purple. So take whatever your other color is, color code that purple.
What happened?
whatever color you're using, just the other one, whatever one you didn't use on the first one. You guys need to share. Can you share those? So instead of starting at the origin, you're gonna go down 2. So instead of starting at 0, 0, you go down 2. The slope didn't change though. The slope is still 1. It's like you just picked up the line and moved it down 2.
What's that Patrick Moscow? What's that Patrick? What is that? What is it?
All right, so those are your vertical translations. Real quick, look at me. Plus means up, minus means down. That's it. Okay. So now we're going to look at steepness. That's where you change like the slope of the line, the amount of up and then over that you go. So when you look at this one, it makes the slope 2 instead of 1. So it is going to make the graph steeper. When you think of a ramp, it would be a ramp that's a little bit harder to walk up because it is steeper. Or you can also say it's greater than 1.
Like a mountain.
Above 1. 2 is bigger than 1. Okay. So if it's a number bigger than 1, like 2 or 3 or 5 or, whatever, it's going to be steeper. So I'm going to take my green color. I'm going to label this one green. Or whatever color you're using, it's fine. You're still gonna start at the origin. We didn't change that, but the slope is now up 2 over 1. So you're gonna go up 2 over 1. And so the point that I'm trying to make, what I'm trying to get you to understand is, do you see how when you compare those 2 lines, the color coded one is steeper than the parent function? Do you see that? Steeper when you compare them? So when you look at the next one, see how it's a 1/4 x? So that is going to be less steep because it is less than 1. A 1/4 is less than 1. So if you have a slope bigger than 1, it's going to be steeper. If it's like a fraction, like 1/4 or 1/3, I guess I should say a fraction, because some fractions are bigger than 1, right? Like if you have 5 halves, like 5 halves is 2.5. That's bigger than 1. Anyway, label that as whatever your other color is.
Hey, if it's less steeper, it'd be steepest.
Okay. You're still going to start at the origin. That didn't change, but you're going to do a slope of a 1/4. So up 1 over 4. And so the point I am trying to make, what I'm trying to get you to understand is, do you see how that line is less steep than the other ones? Like if it was a ramp you were walking up, it would be easier to go up because it's less steep. Is what I'm saying landing for you guys? So the pencil one is the original. Do you see how this one that I did purple, yours might be a different color, but do you see how that's less steep? And do you see how the green one is more steep? Like if you were walking up this green line, it would be harder to walk up because it's steeper. You start at the origin. And for this one, our slope was 2. So I went up 2 over 1. And for this one, it was 1/4. So I started at the origin. I went up 1 over 4. So you're just doing whatever the slope is. You need to cut it out so that I can answer questions for people, okay? Your graphs look good though, so nice job there. All right, so we did vertical shift that moves it up or down. We did changing the steepness that affects the slope. And then the other thing that you can do is a reflection. And so your slope is negative. So you're going to have a negative out front and it's going to just make it go the other way. You guys know what a reflection is, right? Like you look in the mirror backwards.
You see yourself.
Yeah, but you see a reflection of yourself. So it's you the other way around.
so to speak. If both hands up.
So take whatever color you want to use, I suppose. There's only going to be one of these. But instead of a slope of +1, now it's -1. Good. So you're going to start at the origin and just go down 1/1. And again, what I'm trying to get you to understand here is, do you see how it's reflected from the pencil one, the parent function? See how it's the other way around? Or you could be like, it looks like a gigantic X, sort of. So we're going to flip over and answer a few questions using this. And then I'll come around and get the colored pencils back from you. So looking at the first one, what is the slope of this line?
3.
Good, it is 3.
Oh, good.
Now the y-intercept's a little tricky. Anyone want to give it a shot? Good, it's 0 because there's nothing written after that. It's 3x plus nothing. So it's 0. And it would be 0, 0. For the purposes of this, I'm going to just put 0. So vertical translation. If that's still 0, did it move up or down? None. There just wouldn't be one because it's 0. And then the slope tells you the steepness. If your slope is 3, is it steeper, the same, or less steep? Good, because 3 is bigger than 1. It's going to be a steeper line. And was there a reflection? No, because we didn't have a negative. The negative is what gives you the reflection. That's all we're doing, is analyzing this. All right. So look at the next one. What's the slope? 3/5. Very good.
4.
And the y-intercept is 4. So if your y-intercept is 4,
No,
you went up. Plus 4, went up 4.
it was steep.
Now hold on. 3/5. That's a little tricky because it's a fraction. Is that more than 1 or less than 1?
Less than 1.
It's less than 1, so it is less steep.
Steeper.
And did we have a negative for a reflection? No. The x would have to be negative. Okay, so look at this one.
-1.
Your slope is -1, very good. Y-intercept is -3. I'm glad you're getting it, but let's all stay together. So since your y-intercept is -3, it moved down 3. Now this one's a little tricky. There is a reflection because of the negative, but it's -1. So did the steepness change? No, because it's really still just 1. It's just 1 going the other way, but it didn't change. Still 1, it's just a negative instead of a positive. All right, for this one, our slope is -4/3. Y-intercept is -2. So did it move up, down, or none? Down. -2 means it went down. Let me come back to this one. Was there a reflection? Yes, because there was a negative. Now, this is tricky. I'm going to throw the question out there and see if you guys know it. Is 4/3 bigger or smaller than 1? 4/3 is bigger. The way I think of it is 3/3 would be 1. Are you with me here? We need to make a connection between what we're doing right now and when I hand you a test. Okay, 3/3 would be 1, so 4/3 is bigger than 1. And if you're like, hey, what about the negative? Well, that's the reflection part of it. All right, one more of these. Slope is 1/5. Y-intercept 0.7. If you just want to write 7, that's fine. Did it move up, down, or none?
Down.
Up 7. Good. Is 1/5 bigger or smaller than 1?
Smaller.
So less steep. And was there a reflection? No, there's not a negative. Okay, good job. That went well. We're just going to follow up with a few of these. Given this equation, this is how they show up on your test and on the SOL. Make a connection, all right? If you want to move down 2, that means you're going to need to subtract 2. That's what you're going to do. Down 2 means minus 2. So if you take this equation and you subtract 2 off of the end of it, good, it'll be y equals 1/3 x. That part doesn't change. Hey, Miss Cole, looks like you just copied it. Sure did. And then, yes, it would be plus 3. 5 minus 2 is 3. That's literally all you got to do. All right. Given this equation, we want to reflect it. What does that mean? I need to put in front of the 3/4 to do a reflect. Good. Y equals negative 3/4 x. And that's it. All right. We're going to write an equation. So y equals, we want a steeper slope. I'd like a single digit number here, but all you need to do is pick a number bigger than 1.
8.
8. Good. So 8x, we'll make it steeper, is reflected. So instead of 8, I need it to be negative 8. So just shimmy a negative in there. And then we also want to go up 1. So plus 1. Good. All right, it feels like we're getting there. Nice job.
Let's go, guys. One more.
All right, write an equation. So y equals, we want to be less steep. So you need to give me a fraction that's smaller than 1.
1/2.
1/2 is good. But 1/3, 1/10,
1/8.
1/8, whatever. All right. And then is shifted down 3. So minus 3. Perfect.